Good day, viewers. This is Afeademola Johnson. I want to continue from the series of SS1's topics we have been dealing with. Introduction to chemistry. Today we are going to talk about isotopy. Isotopy, by definition, isotopy is the occurrence of two or more than two atoms of the same elements with the same atomic number, but different mass number. So it is possible, just like in a real life, in human being, it is possible we have multiple births, that a parent gives birth to twins or triplets. It's the same thing. Some elements are born, they are created to be twins or triplets in nature. Like in the case of hydrogen, hydrogen is a triplet of protium, deuterium, and protium, deuterium, and tritium. So that is it. Now, there's possibility of having two or more atoms of the same element. They will have the same symbol, but they have the same atomic number, but their mass number is different. So, and there is difference between isotopy and isotopes. Isotopes are the two or more than two atoms of the same elements with the same atomic number but different mass number. So let's look at this is an occurrence. Isotopy is a situation whereby we can have two or more atoms of the same element having the same atomic number but different mass numbers. But the two or more than two atoms of the same element now that isotopy is happening to are isotopes to each other. Let's look at elements that exhibit isotopy. There we have hydrogen, we have chlorine, we have nitrogen, we have carbon, we have oxygen, we have potassium, we have zinc, we have uranium, and so on and so forth. Now, let's look at a table. Let's look at isotopes of hydrogen. Isotopes of hydrogen. Now, for hydrogen, like I told you earlier, I said that hydrogen is triplet. If we are to equate it to human nature, we have 3 types of hydrogen, 3 isotopes of hydrogen. We have 3 isotopes of hydrogen. What are they? There are 3 isotopes of hydrogen. These are: 1, we have hydrogen itself, which is also known as protein, and the symbol is H11. Number 2, so this one has proton number is 1. Don't forget, in our previous class, proton number, which is atomic number, is 1. Then mass number is also 1. And don't forget that neutron number is going to be 0, because neutron number plus proton number gives us mass number. If the proton number is 1, for us to get 1 mass number, the neutron number must go 0. Then another, number 2, isotope of hydrogen is called deuterium. Deuterium, which is H12. In this place, the proton number is what? Is 1. Then the neutron number I told you, if you subtract the proton number from the mass number, you get the neutron number. 2 minus 1 is 1. So that is why the mass number is what? When you add the 2 together, you have these 2. So this mass number is gotten when the proton number and the neutron number are added together. Number 3 example is tritium. Tritium H13. So here the proton number remains 1. The neutron number is what? The neutron number here is, remove this one from this 3, you have 2. Then the mass number will now be 1 plus 2, which is 3, which is this 3. So that is how we come about that. Now, let's check some other ones. Now, let's look at isotopes of chlorine. Chlorine has 2 isotopes. What are they? Number 1, Cl1735. So here now the proton number is 17, which is the atomic number. Then the neutron number will be what? Take away, you have 35, take away 17. So 7, 8, 9, 10, 11, 12, 13, 14, 15, that's 8. That's 18. That's 18. Then the mass number will now be 17 plus 18. That is 35, which is what we have here. Take note of that. Number 2, we have Cl1737. So the proton number still remains the same. It's still what? 17. The neutron number, take away 17 from 37, you have 20. Then the mass number is what? Is what is written here. Add these two together, you have 37. So then we have isotopes of nitrogen. Now, there are 2 isotopes of nitrogen. These are, we have nitrogen 713. The proton number is the atomic number, which is 7. The neutron number is what? Take away 7 from 13. So 7, 8, 9, 10, 11, 12, 10. That's 6. Then the mass number, add these two together. That is this 13 you have. So number 2 example is what? Nitrogen 714. The proton number remains 7. The neutron number, take away 7 from 14, you have another 7. Add them together, you get your mass number. Mass number equals to 14 when you add these two numbers together. So that is how we have them. So let's look at, I haven't talked about the analysis of some of the isotopes. Let's now look at features. Features of isotopes. Number 1, features of isotope. Now, the cause of difference in the mass number of isotopes is due to difference in their neutron number. What am I trying to say here? I've seen a question, they say, which of the following is the major cause of isotopy? Difference in neutron number. Look at the 3 isotopes of hydrogen now. All of them, the 2 of them have the same atomic number. 1, 1, 1. That's what I say. Then occurrence of 2 or more than 2 atoms of the same element having the same atomic number. 1, 1, 1. But different mass number. Why the mass number of this one is 1, mass number of this one is 2, and the mass number of this one is 3. What makes the mass number of this one to be 1 and this one is 2, and this one is 3 is, look at the proton number is the same for everything. Proton number is the same. Proton number is the same. 1, 1, 1. But the difference in neutron number of this one is 0. Neutron number of this one is 1. Neutron number of this one is what? Is 2. So and you know that it is the neutron number that is added to the proton number to give us the mass number. So if what you are adding to the same number is different, therefore you are going to get different results. So take note of that. Number 2. The relative atomic mass to a product of the mean of the mass number of the isotopes. What am I trying to say? E.g., the relative atomic mass of chlorine, Cl, and oxygen is 35.5 and 16.2 respectively. You can see in chlorine, for example, the mass number of one of them is 35, while the mass number of the second is 37. But there is one calculation we are going to later, something that we are going to find the mean, but not the same way we calculate the mathematical mean. We are not adding them together and divide by 2, but there is a way we are going to harmonize the mass number of this mass number, then we get 35.5, which is not a whole number. So take note of that. Number 3 thing to know is that each isotope now has a unique relative abundance. I will explain. Each isotope has a unique relative abundance. What is relative abundance? Relative abundance is the proportion or the percentage of each isotope, the percentage of the existence of each isotopes in every 100% sample of the isotopic element. They asked this definition in recent WAEC defined relative abundance, and it's not in any textbook. What are we trying to say? For instance, in every 100% sample of chlorine gas obtained, now there are 75% of chlorine isotope with mass number 35 and 25% of chlorine isotope with mass number 37. So if you use a cup to collect a sample of chlorine and you divide the the molecules into 100, 75% of it will be the one with mass number 35, smaller mass number, while the remaining 25% is going to be for the chlorine isotope with the mass number 37, the bigger mass number. So take note of that. So this percentage, and that shows that the CN1735 is 3 times more abundant than the chlorine with mass number 37. What am I trying to say? 75 ratio 25. 25 by 1, 25 is 75, 3. It is the same thing as 3 ratio 1. So, because we have, how many 25 do we have in 75? We have 3 of them. So, the chlorine isotope with the mass number 35 is 3 times plenty. I will use that word than the one with mass number 37. So take note. Then feature number 4 to note is that the relative abundance and the relative atomic mass of isotopes are determined with the aid of an electronic device called mass spectrometer. So this mass spectrometer is usually connected to a laptop, a computer. Then you put the gas whose isotopic information you want to get. Then their mass number will be displayed on the screen. Their relative atomic masses and relative abundance will be displayed as well. So that is it. Now, so take note of all these points. With this, we can embark on calculations involved in isotopy. Calculations involved in isotopy. Calculations involved in isotopy. Now, there are 3 major areas where questions are asked about calculations in isotopy. The first one is determination of the relative atomic mass of isotopes. Number 2, that has to do with determination of the missing atomic mass of one of the isotopes. And number 3, determination of the relative abundance of the isotopes. Now, we are going to take them we are going to start taking them one after the other. Now, let's look at the question covering the first one. So this is what I will do for effectiveness. I will give an example, I will solve, then I will give you a classwork to do. Let's look at the first one, calculation on determination of the relative atomic mass of isotopes, isotopic elements. Example, now let me give you two examples. Example one, say chlorine has two isotopes, Cl1735 with the relative abundance of 75% and Cl1737 with the relative abundance of 25%. Find the relative atomic mass of chlorine. So that is a question. What are we giving in this question? We are giving the different mass numbers of the two isotopes and their relative abundance. So what are you going to do when you have this? What I'm going to do is that you say relative atomic mass will now be equal to the first mass number is what? 35. Multiply it with the relative abundance of 75. Add it to get the mass number of the second one, 37. Multiply 37 with its relative abundance of 25. Then add the two abundance 75 plus 25, which will now give us 100%. Now, with what I have here, if I multiply 35 by 75, I get 2625 plus 37 times 25. I have 925. Add it together, I have 100. This one plus 2625. Answer is 3550 over 100 gives us 35.5. I already told you before that the relative atomic mass of isotopes is not a whole number because this is the mean that we're talking about. Take note of that. Another way they can ask you this question, example 2, is that they will say chlorine has two isotopes. The first one with mass number 35 and 37 in the ratio 3 to 1. Find the mean relative atomic mass of chlorine. You will still get 35.5. So relative atomic mass, the same way. The first mass number is what? 35 multiplied by this 3. The second mass number is 37 multiplied by this 1. Add the abundances, the 3 and the 1. So you have 35 times 3 gives me 105. Then 37 times 1 is 37. Over 3 plus 1 is 4. So let's add plus 37. Answer is 142. So 142 over 4. That's still what? 35.5. So that is that. So I give you a classwork. Solve it. And after solving it, snap your solution. You can send me your solution in the comment section. Send it to me in the comment section. Your solution in the comment section. Okay. Now, so the classwork I'm giving you now, number 1, I say oxygen has 2 isotopes, O816 and O818, with the relative abundance of 90% and 10% respectively. What is the meaning of this respectively? It means that 90% is the abundance of the one with mass number 16, while 10% is the abundance of the one with mass number 18. Your answer, expected answer is 16.2. Please take note. Number 2, oxygen has 2 isotopes. That's O816 and O818 in the ratio 9:1. Then you have to find the relative atomic mass of oxygen. So do this. If there's any issue, let me know in the comment section. Then let's look at calculation involving the determination of missing mass number of one of the isotopes. Mind you, this number 1 we just did is the one that can come out in white and echo. But this number 2 we want to do is purely in jam and post-UME. So let's look at the example. Now they say chlorine whose relative has two isotopes. And they will mention the isotopes. Two isotopes, Cl1735 and Cl1737, with the relative abundance. They will not give their relative abundance. The relative abundance of 75% and 25% respectively. Then they now say find. So the mass number of the other one will be missing. Find the value of n, or find the relative atomic mass of this, which is n. The same way, but this time around, they have done this calculation. They have gotten the relative atomic mass to be 35.5. That's why they say chlorine, whose relative atomic mass is 35.5. So when you want to start, and instead of you writing relative atomic mass, you don't write 35.5. Just write 35.5 equals to the first mass number is what? Is 35. 35. What is its abundance? They say with the relative abundance 75% and 25% respectively. 75% is for the first one mentioned, while the second one 25% is for this. So times 75, then plus m. This is the mass number of the second one, m. Its abundance is what? 25%. Then we are adding the two abundances together. 75 plus 25. So we have 35.5 is equal to multiply this 26, 25 plus m times 25 as 25m over add of this one you have 100. Then what do? You cross multiply. So if this is over 1, the whole of this one is multiplying. You have 1 times 2625 plus 25m is equal to 35.5 times what? 100. So use 1 to open this bracket. 1 times this one, 2625. There's an invisible plus here. Plus times plus. 1 times 25m, 25m. Then equals to this one times this one give us 3550. So let me check that. I have 35.5 times 100. Yes, 3550. So what do? We collect the like terms. Take this up to that side. You have 25m equals to 3550 minus 2625. So you have 25m is equals to what? So you have this one minus 2625. Answer is 925. 925. Divide both sides by 25. M equals to 925 divided by 25. Let's see. Divided by 25. Answer is 37. Don't forget, fluorine has two isotopes. One is having mass number 35, while the other one should be having mass number of 37 that we have got in here. Then take your class of 2. Now, oxygen. Class of 2, number 1. Now, the same chlorine, whose relative atomic mass is 35.5, has two isotopes, Cl1735 and Cl17x in the ratio 3:1. Find the value of x. So you can do this. Now, another number 2 that I want to give you, say chlorine. Let me use oxygen now. Oxygen whose relative atomic mass is 16.2 has 2 isotopes. We have O816 and O8Q with the relative abundance of 90% and 10% respectively. Find the value of Q. So that's another one. So let's now look at the third one, determination. Of relative abundance. Of isotopes. Relative abundance. This time around you'll be asked to find the relative abundance. Example is a chlorine whose relative atomic mass is 35.5 has 2 isotopes, Cl1735 and Cl1737. Find the relative abundance of Cl1735. This is the question given to you to be solved. So what do we do? Now, to solve this problem, they are telling us that already they are giving us the relative atomic mass. They have calculated it. They gave us the mass number of the 2 isotopes. We don't know the abundance of the one with mass over 35, which is supposed to be 75%. Now, you will now say, let the relative abundance of Cl1735 that you are looking for be X. Then the relative abundance of the second one now, 37, will now be 100 minus X. That's how to do it. Mind you, if you add that 75% plus 25%, we got 100. So if we know the abundance of one of them to be 75, to know the abundance of the second one, we take this 75 from the 100, it gives us 25. The same thing. If the abundance of one of them is X, then 100 minus X will give us the abundance of the second one. You have been given the relative atomic mass, right? 35.5 is equals to, what then do you do? The mass number of the first one is what? 35. What is the abundance? So I have said let it be X. Then plus second one is 37. What is our abundance? The abundance is over the total abundance will be x plus 100 minus x. So that is that. X is the abundance of the second one. 100 minus x is the abundance of the second one. So we have 35.5 is equal to 35 times x will now be 35x plus, you use this one to open this bracket. 37 times this one will give us 3,700 minus 37 times x, 37x. So then over, then collecting the right hands, this is plus x, this is minus x, they cancel each other. You are left with what? 100. Don't forget, adding abundance together gives you total of 100. So next thing to do is to cross multiply. The whole of this one will multiply 35. Okay, before that, we can simplify this. We have 35.5 is equal to, this is 37 minus 35 minus 37. So give us minus 2x. Then plus what? 3700. So then this is over 100. We cross multiply now. So we have 1 times minus 2x plus 3700. Then equals to what? 35.5 times 100. So using 1 times minus 2x plus times plus 1 times this 3700 equals to, this one is now 3550. Collect the right terms. Take this one there. You have minus 2x is equal to 3550 minus 3700 minus 2x will now give us minus, because what else are we going to get there? We have 3550 minus 3700. Answer is minus 150. So this minus cancels this minus. So x will now be equal to 150 divided by 2. So 150 over 2, that is what? 75%. So that's how to do that. If the abundance of one of them is 75%, take that 75% from 100%, your answer gives you 25%, which is the abundance of the second one. So that's how to do that. So I'm giving you general homework to do to round off this class. Assignments. Number 1, oxygen, whose atomic number, whose relative atomic number is 16.2, has 2 isotopes, O816 and O818. Find the relative abundance of O818. You should know that your expected answer is 10%. So do that. Number 2, an element has a mass of 17. This is a wide question. The element has 2 isotopes. It has 2 isotopes in which their respective number of neutrons is 18 and 20. Then find if their respective relative abundance Find the relative atomic mass of chlorine of the element. So this is a wide question. The proton number is this, which is the same for the two isotopes. The neutron number of the first isotope is 18. Adding 18 to 17, your answer is going to give you mass number of the first isotope. Then adding 17 to 20 gives you the mass number of the second isotope. And you only need mass number and relative abundances. Your work is done. So go ahead and do that. This is a wide question. Then other questions are number 3. Name the instruments used in determining the relative abundance as well as the relative atomic mass of isotopes. Another question here is, why is the relative atomic mass of isotopes not a whole number? I've taught you. Then another thing is, they say consider the following isotopes of neon. This is another wide question. NEX 20, NEY 21, and NE 10, NEZ 22. Which of the following is correct about the isotopes of neon? A, X is greater than Y, greater than Z. B, X is less than Y, less than Z. C, X is equal to Y equals to Z. D, X is greater than Z, greater than Y. So what are they trying to tell you? These are isotopes. They have different mass number. This is 21, 22, 23, 20. But they must have the same atomic number. So X, Y, and Z must be the same. So answer is C. So that is that. Then the same. Okay. Number 6. Consider RTP and QPY. You say, name the phenomenon that gives the relationship between R and T. And of course, the answer is isotopy, because they have the same P and P atomic numbers but different mass number. Why the mass number of this one is T, mass number of this one is Y. So that is isotopy. That's that. Then they can also go further. They say B part now. They say state arrow and Q. So what made them the same? Similarity, equal number of proton number or equal number of atomic number. Then difference is different mass number Y and mass number T. See, you can say name 5 elements that exhibit the phenomenon stated in what? In 6a above, the isotopy. So what are, you have hydrogen, you have chlorine, you have nitrogen, uranium. I listed them, those elements that exhibit that property of isotopy. That's what they are asking you to state. So I've seen a question, they say define isotopy. That's, and they now say using suitable examples, explain isotopy. 2 examples. Don't tell us. See, using suitable example, chlorine 1735 and chlorine 1737. Tell us that in two of them have the same atomic number of 17, but different mass number of 35 and 37. You have explained. You are true. So we are going to stop here. I remain Ademola Johnson. If what I have done here so far, not sleeping at this night, is useful to you, if I have sacrificed for you, just sacrifice for me also. Click the subscribe button, click the notification button in YouTube, and share this video. I remain Ademola Johnson. God bless you. Bye for now. Thank you. If there's any question, please don't hesitate to put in the comment section. God bless you. Thank you.